I've waited so long for this. For what? That jaguar. But we've seen jaguars before. It's just a normal cub. It's not the cub I'm excited about. It's his mama. What mama? Oh! Her! What's wrong with her? Nothing. She just got a little extra pigment. But jaguars are supposed to be tawny, with rosettes. And hamsters are supposed to be small. But look at you. Hey, now shut up. It's a miracle we found any jaguar, let alone a black one with a cub. Be very quiet. We don't want her to notice us. She probably already did. You know, I've been looking at this thing for a while, but I don't really know anything about it. How? I was distracted when Professor Ham was telling me about it. You're an idiot. So are you. Ham and Ham, enough. What is the meaning of all this commotion? He started it. Did not. All right. What are you two looking at anyway? We found this jaguar and her baby. Oh, a melanistic jaguar. That's a rare one. That's what that is. Did you forget what I told you? He did. No. It's all right. I figured you did. Don't worry. I'll tell you guys again. Yay! Now come on. So that jaguar has a mutation called melanism. It means she has an overproduction of melanin, causing her fur and skin to be that dark color. What's a mutation? It's when the genetic code in some sort of organism gets changed. Well, how does that happen? When the enzymes that build your DNA and RNA make a mistake that isn't caught. Sometimes it's silent and doesn't affect the organism. Sometimes it causes a notable change but has no real effect. Sometimes it causes life-threatening conditions or deformities, and sometimes it can even be beneficial. Well, what about melanism? It's just neutral, right? Correct, though it can affect camouflage for better or for worse. It's also theorized that the mutation is able to persist because it strengthens the immune system against viruses. That's so cool. Wait, what mistakes made her look like that? Isn't it something to do with amino acids? Yes, though more specifically with the 301st to the 315th bases that code for those acids in the MC1R gene. Oh, aren't those nucleotides deleted? Yes, without them, the gene can't make its protein, the melanocortin 1 receptor protein. It regulates how much melanin is produced. If the protein isn't produced properly, there's an overproduction of melanin, which makes the jaguar look the way that she does. That makes sense. Thank you, Professor Ham. I'm gonna go get more pictures of her now. Professor? Yeah? I don't get it. How come only 15 bases out of hundreds cause so much trouble? It's only a few. That's a great question. Come here. The screen will help me explain. We're all made of DNA, which makes up your genes. Your genes code for a certain protein that has a certain function, like making your eye the color it is. Your DNA is made of sugars, phosphates, and nucleotides. The nucleotides are what code for the protein. Now the instructions. DNA has 4: adenine, guanine, thymine, and cytosine. The base pairs, A to T and G to C, form the double helix shape of DNA molecules. During protein synthesis, while still in the nucleus, helicase breaks the bonds between the base pairs, splitting the DNA strands into 2. Then, this strand of mRNA comes in to have RNA polymerase build the base pairs complementary to those on that part of the DNA. However, Instead of thymine, the polymerase will make uracil. Kind of like when you want to translate something from English to Spanish. Guanine to cytosine are cognates, and thymine to uracil are everything else. This step is called transcription. It's the first step to protein synthesis and produces mRNA. As you can see, this piece of mRNA has the missing bases that would otherwise complete the sequence and produce the MC1R protein. mRNA contains ribose, phosphates, and nucleotides. Everything in nucleotides makes up a codon, which is the code for a certain amino acid. The mRNA is the template for the rest of protein synthesis. Once built, it leaves the nucleus through a tear in the nuclear envelope and heads for a ribosome. The next step to this process is called translation, which takes place in the ribosome. The ribosome has two pockets made up of rRNA, which is a structural type of RNA. The mRNA will enter these areas one codon at a time. Then, tRNA will enter the ribosome. It contains anticodons, which are complementary to the mRNA's codons. It acts as a translator, with the anticodons binding to the codons and creating whatever amino acid is being coded for by the mRNA codon, creating a chain at the back of the tRNA molecule. Think of the tRNA as assembly line workers putting together pieces of a product. The mRNA is on a conveyor belt, with the nucleotides being the pieces of a product. Once this process is complete, the amino acid will join a peptide chain, which is bonded by peptide bonds. Eventually, all the amino acids will become part of it, creating a protein. In this case, it would create the melanocortin-1 receptor, which, as I said before, is intended to regulate the amount of melanin produced in a certain area. The reason this protein doesn't function in this jaguar is because without these specific bases, important amino acids are missing from the peptide chain, causing the protein to be unable to function properly and regulate the amount of melanin produced.
That's a lot, but it makes sense. But isn't the mutation dominant? How come the jaguar had a normal cub?
Well, think of it like this. The uppercase B is the mutated gene, and the lowercase b is the normal gene. The jaguar cub's mama would have one uppercase b and one lowercase b. Even if she had that cub with another melanistic jaguar, there's still a 25% chance he would be normal. So there'd also be a 25% chance that he'd have two copies of this mutation, which would be two uppercase B's. However, regardless of whether or not he expresses this mutation, he would still be a carrier for it. The odds of him simply being a carrier only increase if she had him with a normal jaguar.
Huh. I didn't know that. Makes a lot of sense now, Professor.
Good. Now, go with him so I can take a walk. I need some fresh air. What a day it has been. What's that sound?